Okay, here is the video guide for lesson 4.1.3. We're going to be expanding our trig table. So in the previous lessons, we figured out our first four slope angles and slope ratios. In the second lesson, we practiced them and found out that complementary reciprocal. So if we had 22, we could also find 68 because they're just reciprocals. The slope ratios are reciprocals. Today, we're going to find some ones that are not as nice by just exploring some e-tools. And we're going to keep these three questions in mind. Okay, what happens to the slope ratio when the angle increases and decreases? What happens when the slope ratio is 0 or 90? And then when is the slope ratio more than 1? When is it less than 1? Those questions are going to be addressed in our learning log. Looking at this first question, it says to graph on the right, do a slope triangle with the slope angle of 45. Well, I know the slope ratio for a 45-degree slope angle is 1 to 1, so that means it's going to go over 1, up 1, over 1, up 1, over 1, up 1, and we're going to get our line created that way. Okay, and I'm just going to create a slope triangle based off of that. And the question's asking us, now this right here is our 45-degree angle. This right here is our 45-degree angle. If that was bumped up to a 55-degree angle, which would become longer? The change in y, would it get taller? Or would the change in x change? Would it get longer on the bottom? Okay, and I just want you to explain your reasoning why you think the y would get taller or why you think the x would get longer. Here is the first one that is going to be similar to the rest of the problems in this lesson. So it says on the tool on the right, create a triangle with a slope angle measure of 55 degrees, then use the resulting slope to solve for x. We're going to do a lot of these kind of problems here today. So what you're going to do is you can see as I move this green dot, it changes the slope angle and it changes the slope ratio. And so what you can do is you can put it at a 55-degree angle, and you'll see that this is 1.43, always round to this 10th spot here. So that's really like 1.4. And the reason I have you do that is because look at when you have a 55-degree angle, there's different 55-degree angles there. You could have 1.44 or 1.43, you could have 1.45, you could have 1.40. So I just like to round there to get everybody somewhat close to the same page. We're still going to get some different answers because of that little difference in the e-tool. But when you have that slope ratio, then what you can do is, okay, say, and I want to see this in your work, so show everything very vividly or very clearly. All right, that would be like 1.4 over 1, set equal to the ratio of the triangle, which would be rise over run 8 over x, okay? And I want you to set it up every one like this, or at least some variation of this, so I can see what slope ratio you're using, and then I can see your work and how it could vary from person to person, because maybe somebody doesn't listen to this and they use 1.43 or 1.44 and they're getting different answers. Well, if I see the work, I can explain why you're getting different answers and how it's okay that you're getting different answers. Okay? Like I said, a lot of these problems are just like that. So you have to put this one at a 7-degree angle, round this to 2.7. So again, that would be like, if I want to set up my slope ratio, that's 2.7 over 1. I can set that equal to what I'm given, rise over run, that would be like y over 10, and I can solve this for y. Okay? Now you could try to mess with this and get this to be an x of 10 and then figure out where the y would be if you got to 70 degrees. The issue I've had is I've seen that not be super accurate on this e-tool. I would rather you practice your calculation skills like I've shown down here with your cross multiplying or however you go about solving it like we did on Monday or Tuesday. Keep going. You can see one now where you are going to have to control the e-tool. And so like if you want to figure out what this theta is, what the angle is, well then you got to move the green dot so that your y is 50 and that your x is 6. And it might take you a second or two, but once you get it, like I have there, you can see that that creates an 83-degree angle. So I can answer my question there with an 83-degree angle. So the e-tools here are nice to help us do these ones especially. Here you can see that we have, again, you got to move your y and your x to figure out what your angle is. Here we have to move to an 8-degree angle and then do what we were doing before. So again, using your slope ratio here, be careful and make sure you round to that 10th spot, which looks like 0.1. And so then we can use 0.1 over 1 and solve for your x. Here, this is going to evaluate that question. Okay, what does it look like when you have 0 as your height? All right, and can it create a triangle, yes or no? And then what would the slope ratio be? Even if it cannot create a triangle, what would the slope ratio be? And you could write both of it. Okay, it doesn't create a triangle, but it would have this slope ratio. And I think we talked about this one a little bit on Monday or Tuesday, whatever day I had you. All right, here we have another one where you need to get an 89-degree angle and then solve for y. Again, you have to just work to get at that 89 and then use the slope ratio, round to the nearest 10th spot next to the decimal there, and then figure out, your y. So rise over run. Same as the other problem, so that's why I'm kind of going quickly through it. Okay, same kind of thing here. What if you had a 90-degree slope angle? Okay, what is our slope ratio? And can it create a triangle? Same kind of question. Here we have, once you have everything done in this lesson, you're going to go back through and you're going to add things to your trig table. You're going to add angle measurements and new slope ratios to your trig table. So some of them, like you could have 89 filled in because you could have a slope ratio for 89. And remember, the slope ratio here is always over 1. So if you, well, that's kind of lucky here. This is 89. It says my slope ratio is 40.23. Well, I round that to the 10th spot, so that's 40.2. So when I put it in my trig table, I say, okay, the 89-degree angle has a slope ratio of 40.2 over 1. Okay, and you can go back and fill out your entire trig table. And then we're going to answer the 3 big questions from the beginning of the lesson. What happens to the slope ratio when the angle increases, decreases? What happens to the slope ratio when the angle is 0 or 90? And when is the slope ratio more than 1 or less than 1? And then your understanding check right here. If you have questions throughout the lesson, please let me know. I think this one will be a good one for us, especially if we were very serious and got a good understanding of the Monday and Tuesday lessons that really introed this idea.